Hey, want to see some science? Follow me. Check this out. Today, we're learning about energy transformations and electricity production using steam. What we've got here is a little mini steam generator. We're looking at a hot plate with electricity flowing through a pipe. Our hot plate converts that electricity to thermal energy, which is transferred to our water. The water boils at 212 degrees Fahrenheit, turns to steam. The steam is trapped in this flask, and we get thermal energy converted to mechanical energy as our steam escapes. We can do it one better. We can get the steam to escape a little quicker by constricting this and building up pressure inside here, okay? As the pressure builds in the flask, as the steam builds up in the flask, the pressure increases inside of there. Now we've got steam escaping out this small hole. In nature, everything flows from high to low, including high pressure to low pressure. We can see this flow of steam happening here. So check this out. Here's what we're going to try to do. In a power plant, we use fast-flowing steam to spin a turbine. I've got my little turbine right here. We'll see if we can get this thing to spin. So we're going to take our glass tube here. We're going to add it in there. And now we've got steam flowing through this tube, 90-degree angle out to here. Let's see if it'll spin our turbine. Ooh, not really. We don't have quite enough steam flow here to get it to spin. What's going on? I don't know. There must be some inefficiencies in our system. I think the first one could be this 90-degree bend. Anytime we get that flow to come around a corner, we're losing energy there. We're slowing down our steam. That's a loss of mechanical energy. How can we make it more efficient? Oh, I don't know. Let's straighten our pipe here. Let's get this straight tube. And now we've got a little faster flow of energy here. Let's see if we can now get our turbine to spin. Okay, we've got a little bit of energy transfer going on here now. We're transferring the mechanical energy from this steam directly to our turbine. Now we've got a spinning turbine, and we can just barely get it to move at that pressure. We can do it one better. I have a funny feeling if we keep the pipe straight and we restrict the end there, we have a lot of steam forcing its way through a much smaller area. We get higher pressure, and we make it a faster flow, similar to how your pressure washer you may clean your deck or something with works. Let's hear. Ooh, it's already louder. I can hear it. That's a sign we've got higher energy. That's a sign we've got faster flowing steam. Here we go. Let's check it out. Okay, that's what you want right there. That is a direct transfer of mechanical energy from fast flowing steam to a turbine. And that's a beautiful thing. We see this all over the place in industrial electricity production. We would see it in a biomass power plant where we burn wood chips to make steam. We'd see it in a fossil fuels power plant where we burn coal. We'd see it in a nuclear power plant where we use radiation to produce hot water and steam. Many different examples, and even geothermal energy where we get hot water from beneath the earth to boil and make steam. So steam is our friend. We use it to spin steam turbines. There's all kinds of inefficiencies in the system that we could fix. We could insulate the flask here to keep more of that heat in, make even more steam. Lots of examples of ways we can make this more efficient, but it's a classic example of the use of steam to spin a steam turbine. And in our world, that's very important to help the lights come on. Thanks for checking out some science with Mr. Delcourt.